Video is meant to talk through page 4 of lesson 4 for the CT STEM curriculum. So now we started last page by looking at behavior of the overall system. Now we are looking at behavior of individual molecules. So we're using the same simulation, but this time we're going to be observing individual molecules. Okay, so just like before, I'm scrolling down to see what my questions are. Okay, so what must occur for an ionic bond to break and for potassium chloride to separate? It takes the potassium chloride noticeably longer to separate into cations and anions. Describe why this is so. Okay, so this question is asking us to compare what's happening here to what was happening on the previous screen. The next question is calculate the change in temperature for the system by recording the initial and final temperatures of the system below. And again, you can hover over the actual line here and it'll tell you what the temperature is. Compare your question answer. Okay, so you're going to compare this answer to what the temperature change was in the previous page. Are they identical? Why not? And then next one, start the simulation over and press track a water molecule. Wait for the water molecule to collide with potassium chloride. What observation can you make? Okay, so it sounds like we're doing this after we just figure out what the change in the system is, or change in the temperature is. Explain why you think change in relative speed of water molecule occurs. So where is the energy going? And finally, based on your observations of the simulation, make a claim. Okay, so remember, anytime we are making a claim, we are trying to say something that is valid based off of evidence that we can gather. So make a claim of what molecular interaction could cause the kinetic energy of the water molecules to increase. Okay, so going back up here, we are adjusting, so we have 10 water molecules. Okay, so already this is a little bit of a different setup than the page before. The page before we had 100 water molecules, now we have 10. We are going to press setup, and we see that our 10 water molecules, and then we press go. And if you hover over, you see that it's number of ticks, comma, temperature. So right now the temperature within this beaker is 300 Kelvin. Okay, so now add KCl and allow this to run until all of the potassium chloride is split into anions and cations. And it takes a little bit of time. If you want to make it go faster, you can make it go faster by increasing the tick speed. But this page simulation will take a lot longer. It's important here to think through what is causing the potassium chlorides to break up. Why is it that this is going slower? What is the difference between this simulation and the simulation we were running on the previous page? Like, what is the difference in setup? These are the things you should be thinking through as you're watching this. Okay, so we're just going to kind of keep running the simulation. You will need to run it a couple other times because obviously you need to track the water molecule, okay? But you want to make sure just answer the questions to the best of your ability.